quickly asked to do questions 5 and 7. Basically the same question. I'll do question 7. Okay. To do question 7, all you're asked to do is we're only doing with a calculator. There's absolutely no need for a calculator. Okay. So we press mode. We go to stat mode, number 2. Okay, I'm already in mode, stat mode. Now we're going to do one variable. Notice the frequency. Is there anybody without the frequency? Okay, so if frequency is gone, press shift, setup, stat to find the frequency. 1. Okay, entering the numbers on the left. 2 equals 4 equals 5 equals 7 equals 11 equals 13 equals. Okay, stop there. Okay, now guys, what we're going to do next is we're going to go to shift, stats. Now there's 4 variables here. Okay, can anybody tell me what the first 3 mean? What does n mean? The amount of numbers you have. Can anybody predict the n value? 1, 2, 3, 4, 5, 6. The mean would be the average. Okay, so if I press 2, the average of these numbers is 7. Is that okay? And then finally, shift, stat, go to number 4 again. What's the third one mean? Deviation. What does that mean? Huh? No, it's a measure of how much it deviates from the middle. So 3.87. Now, what I'd argue here is that 3.87. Okay, what did we say the mean was earlier? The mean was 7, wasn't it? So standard deviation is 3.87. The mean, the mean was 7. So does everybody get that the average is 7? But what does standard deviation even mean? It's a measure of how far away your answers are from the mean. So imagine this, okay? Imagine that I changed these two values. Imagine I changed the 2 into a 0, and imagine I changed the 13 into a 20. What do you think will be the result for the standard deviation? Sorry? Bigger, yeah? Actually, I'm not going to keep that as a 20. I actually have no idea. If I take 2 away from, see the way I take 2 away from 2 to turn it into 0, yeah? And then I add 2 on the 13 to turn it into 15, yeah? Would you agree that the average is going to be the same? Because the grand total of all 6 numbers is still the same. So my prediction is, if I turn the 2 into a 0 and turn the last number into a 15, my prediction is that the mean will still be 7. I can find that out quite quickly by going shift, stat, I'm going into my data now. I'm going to make the adjustment. I'm going to turn the first one into 0 and the last one into 15. Okay, going to do the same trick again. Shift, stat, go into the variables. I'm checking out the mean. The mean is still 7 as predicted. Can somebody in class make me a prediction on what's going to happen to the standard deviation? Up or down? Up or down? Think about it. The 7 here, yeah? The 7 is the mean. 13 is 6 away from the mean. And the 2 is 5 away from the mean. I've replaced them with 2 numbers. One of them which is 7 away from the mean, and the other one which is 8 away from the mean. I've increased the distance from the mean of 2 of the numbers. This means that it deviates more. Remember, it's talking about the mean. How close are your scores to the mean is basically what standard deviation stands for. And I've now increased their distance from the mean, which means the prediction we should make is that I'm expecting a bigger standard deviation than before. Let's verify that by checking it out. Shift, stat, variable, standard deviation. As predicted, it was 3.7. Now it's gone to 4.86. Okay. Make a second prediction for me, okay? if I was to once again mess around with my last set of numbers here, okay? And what I'm going to do this time is, what am I going to do this time, okay? This time I'm going to keep the 7 and the 5 where they are, okay? But I'm going to reduce the 11 by 2. Is everybody happy with that? I'm going to reduce the 11 by 2, which turns it into a 9. I'm going to reroute this 2 to the 4, so I have 4, 4, 5, 7, 9, 13. What have I actually done here? Have I brought the numbers closer to the mean or further away? Closer. As a result, would you predict a higher or lower standard deviation than 3.87? A lower, and you'd be correct if you were to calculate it out. Okay? I'm going to do another trick here. Okay? Can anyone in the class predict the following, okay? X bar was 7 and the standard deviation was 3.87. I'm going to increase everything by the same number. I'm going to think of a new set of numbers. I'm going to call that one 4, 6, 7, 9, 13, 15. Can anybody, without using the calculator, tell me the new mean? What's the new mean of these numbers? I increased every number by how much? How did I affect the average then? If I increased every result by 2, you're right. The new mean is going to be 9. Because the old mean was 7, I increased every number by 2. So that means that the new mean is going to be 9. Can anybody predict the standard deviation? Well done. Who said? 2 people knew it was the same. How did you know it was the same? I did because I increased them by equal amounts. I didn't change how far away the numbers were from the mean. Okay? So standard deviation remains the same. On a really, really basic level, okay? If you want to let this off by heart, right? Really basic level is the lower the standard deviation, the closer the answers are to the mean. The bigger the standard deviation, the further away all your data is from the mean. Okay? Second thing is, if I pick any one of these data sets and I increase every number by the same amount, yeah? When I increase every number by the same amount by adding, it doesn't affect the standard deviation, okay? So look, we're going to do a little task. Everybody in the class is going to do a task, okay? We're going to pick 4 numbers, okay? Oh, sorry, 5 numbers. Give me 5 numbers in between 1 and 15, Connor. Yeah. Yeah. 12, 13, okay? That's the blue set, okay? What I want you to do next is pick a number to increase every number by. 4, yeah? This we call the green set. So that's going to be 7, 11, 14, 16 and 17. Is everybody happy with that? And then finally the red set. The red set is going to be pick a number to multiply every one of them by. 2, yeah? I'm going to double it. So 6, 14, 20, 24 and 26. That's what I want you to do in class. Will you 3 do the blue set? Find the standard deviation of the blue set. Sean, middle class, you do the standard deviation of the green set and the mean of the green set, and you do the standard deviation of the red set. Okay, and we'll come back with all 3 sets of answers, okay? So what's going to happen next, guys, is first of all, let's start off with the blue one, okay? What's the blue one? Who's got blue? 9. 3.63, okay? Now, the blue set was our original one, okay? The original set was a mean of 9 and a standard deviation of 3.63. Now, however, the next thing we did was we decided to add the number 4 onto every number to create the green set. Before anybody in the green set tells me the answer, you make a prediction on the new mean. If you add 4 onto every one of them, it has to result in a higher average, surely. If each one of your marks is increased by 4, What has to result in? 13. That was green, guys. As green, guys, 13. 1 sec. Stop. Shh. Okay. Next prediction. Will the standard deviation stay the same? Why? It's the same spread of results. They're still the same distance away as they were before. Okay? If you imagine 9 to be the middle, okay? If 9 was the old one, shh, lads, please pay attention here. They do ask this, okay? 9 was the old one. The bottom score was 6 marks away from the mean. Your new mean is 13, yet your bottom score of 7 is still 6 marks away. It means the standard deviation hasn't changed because there's no increase in the gap. However, can anybody make a prediction on the red group? What is the new mean? It's... Huh? It's 7 point... Sorry, the standard deviation's double. So you got 7 points. Is the standard deviation 7.2? Okay, we'll just check this data out myself, okay? I'm going to do the red one myself. That's the job done yourself sometimes. 14, 20, 24, 26. Okay, wait, guys. Stats. Variable 2. 18, as predicted. Double the mean of the old one. If you multiply every score by 2, you're doubling your total number of points. Therefore, you're doubling your mean, which means it's 18, which as predicted. Now, remember, the distance between our lowest score, which is 6, and our mean is, what's the difference? 12. It used to be 6. We've actually doubled the distances, haven't we? Now, whether that results in doubling the standard deviation or not, we'll find out. Shift stat, variable standard deviation, 7.26. Safe to say, when you multiply the mean by the same amount, and you multiply the standard deviation by the same amount. When you add, you increase the mean by the amount you added on, but the standard deviation stays the same. Okay, that's very important stuff, guys, okay? They do like to ask that type of question. Now, yes, John. Next thing, CAO points. Okay, guys? So, we have what's called the, if you will, we have what's called the standard curve. And you'll often hear of people standardizing tests. Okay? Now, here's what happens. You have what's called the mean standard curve. Okay, this is the average. It's dead center. Okay. Now, the average CAO points every year is 350 for the most part. 350 more or less. That means if you get 350, it means 50% of the population is behind you, and 50% of people are above you, or a decimal of that, like 49.999, 50.001, something like that. More or less, half the people have a better result than you, half the people have a lower result than you. Is that okay? Now, what happens next is the use of standard deviation in statistics to basically they want to find out how much of the population resides in a certain interval. Okay, so if the standard deviation is 80, as an example, there's a rule called the empirical rule, and I'll show you what the empirical rule is now. And you have to take this down, know it off by heart. Empirical rule is this: your mean minus the standard deviation, and your mean plus the standard deviation is always 68% of the population. As a result, 350 take away one standard deviation. 350, 270. So if I mark 270 on the scale here, and then I do the standard deviation, what's that? Now what this means is that if I ask you guys, how many people have got a score between 270 and 430, what should you tell me? 68% every time. Plus 1 standard deviation and minus 1 standard deviation always results in 68% of the population scoring these two numbers. We now move on to the second part. The second part is what happens when it's 2 standard deviations away. So instead of 1 standard deviation, we're now going to have 2 standard deviations away. So we'll rub out this here, the 270. Now, what's 350 minus 2 80s in a row? It's 350 minus 160, which is 190. 190 is a bit further away. And what about 350 plus 2 standard deviations? 510, which is pretty good points, to be honest. Okay. Now, here's something here, guys. In between these two results, we'll decide 95% of the population. Is everybody happy with that? 95% of the population. Now, here's a bit of a trick here as well, okay? If 95% of the population is accounted for, what percent of the population is not accounted for? 5%. So 5% is unaccounted for. 2.5% is located this way, and the other 2.5% is that way, because it's symmetrical. Okay? Now, if I asked you, if you got 510 points, how many people have a better score than you? How many people have a lower score than you? 97.5. Yes? It's what's called a standardized curve. In reality, it's not perfectly symmetrical, but it's close enough to symmetrical that it can be modeled that way. No maths model is 100% exact. Okay? Now, finally, there's one last one, and it's called 3 standard deviations away. So instead of 2 standard deviations away, you're going to go 3 standard deviations away. When you do this, you end up locking up 99.7% of the population. Okay? Pretty much all the population will be between these two scores. So, 350 take away 3 standard deviations. What do they say standard deviation is again? 80. 3 multiplied by 80 is 110. So, we're shifting it down again. We're down all the way here, 110. Okay? And then the other end, we're at 590. Now, here's the deal. You're going to know very few people. Now, more so in southeast Dublin, you're going to have a few more people over 590 than expected. If you go to more working class places, those people getting over 590, like, they're much rarer. Okay? So, basically, in between this region here is 99.7% of the entire population. Okay? So, in summary, okay, whatever question they give you, whatever it is, you say, mean minus standard deviation, mean plus standard deviation, how many people are there? 68. That's the first thing. Go second one. Mean minus 2 times standard deviation, mean plus 2 times standard deviation. How many people? 95. And finally, learned off by heart, mean minus 3 times standard deviation, mean plus 3 times standard deviation. 99.7. Off by heart up here. It's not in your notes anywhere. Okay? Now, it's in your book under empirical rule. On what page are you on, guys? Page 100. Okay, that's it there in the book. That is 99.7. Okay, can we move on? Yeah, hurry up. Okay, guys. Shh. Would everybody agree that's a very easy question? Just use your calculator to calculate the mean. Use it to calculate the standard deviation, and then it's the mean minus the standard deviation equals 1. It's a very easy question. Okay, let's move on to something a bit more better. Okay, common in which machine is more. Find the standard deviation. Lads on the left, do the red one. Lads on the right, do the blue one. I want the standard deviations of both machines. Can anybody tell me, what does a lower standard deviation mean for this? It means it's a more reliable machine. If the machine had a 0 standard deviation, it would make 195 or 197 every time. If it has no standard deviation, it makes the same size every time. These machines have errors in them. The bigger the standard deviation, the bigger the error. So what's the red one, anybody? 2 point. Okay, and what's the blue one? What? Okay, and as predicted, okay, we can see that the bottom machine is the least reliable one because it has the higher standard deviation. Another source would be that if you get the range, the highest value minus the lowest value. The top one is 9, but the bottom one is 15. 15 on the range on the bottom one compared to the top one. Okay. Now, finally, 18. Masses of group of students are found to be approximately normal. Normal means it obeys the normal curve. It obeys the empirical rule. The mean is 62. Can anybody therefore tell me what is the value of P? 62. Mean always goes dead center. The standard deviation is 6. Can anybody tell me what R is? R is 1 standard deviation away, which is 56. That's going to be 2 standard deviations away, which is, and then 44. Okay? And I don't know, it's going in 6s. Next one, 68 and 74, 80. Okay. Okay, guys. Here's what I want. I'm going to ask you a couple of questions. You guys got to tell me the answer, okay? So using the information above, we're going to go one step further, okay? What I'm going to ask you is this. How many people are there in between 56 and 68? 68%. One deviation either side results in 68% population being there. Okay, can anybody tell me how many are in between? Okay. I'll go a bit harder at 50 and 74. Okay. Yeah. Yep. Yeah, I know it can go that way, but it doesn't have to go that way. So let me show you how to do this one. Okay. Oh, are they both 2 away from each other? Oh yeah, sorry, you're right. 95 is 2 standard deviations to the left, 2 standard deviations to the right, 95%. Now, if I want to make this a bit harder, and if I was really trying to test who's who, what I'd do is this one here. I'd ask you what is the in between 68 and 50. Now let me show you how to do this one. Okay? You said that in between here and here, and if it was the same on the other side, it'd be 95%, right? So if I half that, I can tell you that that's 47.5%. And if this one was halved, it'd be 34. And then if I add them both together, it'd be 40. It'd be 47.5 plus 34. Roughly give you what's it? 81.5. Okay, that's it. Now,